All right, we're straight into it. No
Just
starting
straight into it.
soon.
No starting soon. All
We're
right.
here. We're ready. Jose, how you doing, man?
I'm doing good, brother. How about you? How
I'm
about
doing
you?
good, doing good. Busy
Hey.
week coming up.
Yeah,
Got an
yeah.
exam tomorrow
Busy.
and stuff.
Yeah, we got an exam tomorrow, and then today is a little bit busy because we got our club going on. We got class. We got the live stream. So,
Yeah,
yeah. So today is a little bit of a tough one, right? But
yeah.
hey, we still here though.
And then
We still here.
I gotta get you your gift, and then yeah, it's busy.
Nah, nah,
It's
nah,
busy.
bro.
It's
It's okay,
busy.
bro.
I already know what I'm gonna get you, man. I already know.
I
So
bet. I
don't worry.
bet.
Don't you
Yeah.
worry.
Now, if you want to, right, I'm not gonna take part into it, right? Because I don't feel like it's right. But if you still want to, I'm gonna let you decide. Let you go for it.
Yeah. Can you guess like what I'm thinking?
I think it has to do with a panda.
Okay. All
I
right.
don't know, baby. I don't know, baby. Yeah.
We'll
I'm
see.
leave it
We'll
up to
see.
you.
I don't
We'll
know.
see. We'll see. We'll see. We'll see.
But
Uh,
anyways, what you been up to? What you got?
Not much, brother. I've been doing some homeworks. This semester is loaded with projects. Like for all my classes, I have projects plus the projects that we have for our personal project.
Mm-hmm.
So it's just like trying to manage what to do, what try to get like a timeline so I can finish them correctly, work on this one over here, this one over there. And they don't have no correlation between each other. So it's like you have to like switch your mindset to work on something, then switch it again to another thing. Right.
Wow.
But other than that, it's pretty chill. How about yours? How's everything?
Well, I kind of got caught off guard yesterday with the homework that was due today.
Yeah.
Actually, yeah,
Uh-huh.
no, it was gonna be due yesterday, but then
Yeah.
they ended up extending it. I'm not gonna say what I did to make sure I got the homework finished, but um, I got it done. I ended up turning it in, and then he extended the homework. So then I was like, well, I guess everything happens for a reason. So
Everything happens for a reason. Yeah.
yeah, but it does have correlation to what I'm gonna get Jose today. So I'm just gonna. That's all I'm gonna say. But um, other than that, I think this week is mainly focused on the exam for tomorrow,
Yeah.
and
Uh-huh.
then continue grinding LeetCode, like I told you,
Yeah.
and then also get our project started and getting ready for Rowdy Hacks. I think those are the main things
Oh, bro, I'm
coming
excited for
up.
routing hacks, brother. I've
Yeah,
been learning some stuff, bro. Ooh, I feel the power in my veins, bro. I feel
really.
bro. I feel the power flowing through my veins, bro. I'm ready, dude.
Yeah,
Mm. But if it's good with you, you wanna start this
yeah.
leak
Let's get
code
started.
grind?
Let's get
Yeah.
started.
All
So
right.
we're currently at trees. We're still at trees. We
Yeah.
completed all these other categories. Um, Starting from I don't know when, but uh, so yeah, we got two problems in the horizon: lowest common ancestor of a binary search tree, and then binary tree level order traversal. So that's what we're gonna try
Yeah.
to accomplish today. Um, I want to make sure the music is being heard in the background. So no
I can verify
disturbances.
that.
All right, I'm good.
Yeah, you're good.
Yeah, we got it. We got
Alrighty.
it.
Okay. Bet.
All right, you want to start?
Yeah, I can start it off. I can read it. I can read
Okay.
this one. All right, so we got problem 235, lowest common ancestor of a binary search tree. This is a medium problem, and it says the following. Given a binary search tree, find the lowest common ancestor node of two given nodes in the binary search tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes, P and Q, as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Example 1, we're given an input of that binary tree with P being 2 and Q being 8. The output is 6, and the explanation is that the lowest common ancestor of node 2 and 8 is 6, since 2 and 8 are descendants of 6. Sample 2, we're given that binary search tree, and we're given P as 2 and Q as 4, output of 2. Since the lowest common ancestor of the nodes 2 and 4 is 2, since the node can be the descendant of itself according to the lowest common ancestor definition. Okay.
This one,
Oh.
this one we'll just skip.
Yeah.
But okay. I think we reviewed this last stream.
Yes.
And we misunderstood, or at least I did. I misunderstood it a little bit, but thankfully after we reviewed it a little bit more, we kind of understood what it meant by a descendant. A node could be a descendant of itself. So that's shown here. For example, 2. That 2 is considered a descendant of itself. So that's why we return to 2 as the lowest descendant.
Yeah.
Which is very interesting. So that means there's no duplicate value nodes, correct?
I feel like in the constraints, I was looking at them right now and said that nodes are unique. P and Q cannot be the same, and P, Q are in the binary search tree.
Okay, perfect.
Yeah.
So that's perfect because obviously there can't be another 2 over here or something, and then that brings a whole nother issue. So so that makes sense. Do you think we need to take it to the drawing board and kind of describe what we want to do, or what are you thinking?
I think so, just to get like a better approach, better understanding how to approach it, right?
All right.
And yeah. All right, I'm here too. So let me see. Okay, right there. So I was thinking of doing a post order traversal.
Okay.
Yeah, where we're gonna loop through the 0 first, then the 3, then the 5, then the 4, then the 2, right?
Okay.
And then from here we're gonna go to the 7, to the 9, to the 8, and to the 6, right? So we're gonna do a little bit of post order, and then we just check if the values correlate to each other, and then we just return that value. If they're equal, we return true, right? If it's found on like the left side, we return true. If it's found on the right side, we return true. And wherever those two values are true, we return that node because that's a parent of both children. So we're gonna loop through each of them and be like, all right, is 0 equal to P or Q, 3 P or Q, 5, 10. The same, we're gonna check the 4, 2. And if one of them is true, we're gonna return true to the parent, in this case 2. Right? And then we're gonna go to the right side and we're gonna check, hey, is this 2? Is P and Q found in here? And if we get both trues on 2, we return 2. I don't know if that makes sense. Yeah or nay?
So you're saying for this example, you said P is what? P equals 0?
P equals 2 and 8.
No, but for this one you said
yes.
0.
Yeah, 0.
And then Q equals what?
Q equals, let's call it 5.
5. So you're saying that you're doing post order, correct? And that starts right here?
Yes.
Order starts right here. Okay. And then this one is equal to P. So that one hits true.
Yeah.
And then you check 3.
We check 3.
Then that one doesn't equal Q. Then you check 5. That one's equals Q.
Yeah.
So how do you know? I have 2 questions. How do you know that you don't go to this node, and say that that's the parent or that's the lowest descendant?
Oh, okay. I see.
And then you end up saying that this one.
Okay, I get you.
Or do you compare the level? Like, how would you compare? There's a way I would think, and it's you compare the level of these 2 nodes, and which one's higher, you're gonna get that parent of it, because that means, you know what I'm saying? But I don't know what you're thinking.
Well, if we go like that, what if 0 it's over here, right? And we got like extra nodes over here. or 0 it's one more and 5 is over here, right? And we say, all right, since 0 we can just get the above one, we're gonna return as a parent as 0 as the
Yeah,
root.
well, that's the other
Yeah.
question: is how do you know what side of the tree it's on? And that was gonna be my second
Yeah,
question.
yeah. Well, this is gonna be a recursive method, right? So we're gonna go to the left, right, left, right. We're gonna recurse left,
Where are
and
you
then
going at?
uh,
Oh,
oh,
my bad. You're over here.
yeah, yeah, yeah.
Keep going.
Sorry. Yeah. So we're gonna recurse left, right? Let me see. Let me instead of writing, I'm gonna use a text box.
Wait.
Large, no, extra. So we're gonna do recurse left, right? And we're gonna store it in a variable called left, right? So we're gonna recurse left. It's gonna go 2, 0, 4 all the way to left, and as soon as we hit 0, we're gonna return true, and now left is gonna equal to true, right? Now we're gonna go to right and recurse right, right? And it's gonna go check if in the subtree, in this subtree, there's a 5 in there, and if so, we're gonna return true. And at the end, we're gonna say return L and R, right? And if there's, we're gonna return true, right? And then if we don't find that there's one of them in that subtree, if there's no 5 or 0, this is gonna be false, right? And then this is gonna return false.
Well, we need to return the value of the lowest
Oh
descendant.
yes. If P is equal to val dot no, root dot val, right? We're gonna return true. Else if Q equal root dot val, return true, right? So we're gonna return true if we find P, return true if we see Q, right? One of those. Then as soon as we get those two values, right, we're gonna return to L and to R, right, and then we're gonna hit the system right here. Yay or nay?
But how do you return the root val?
That's interesting. You got me there. Because we want to return.
Would it
That
be
is.
like if L and R are true, then return root dot val or
Oh, return val. Return
return
val.
val or that, right?
Yeah.
Something along the lines of that.
That's yeah. If return return root. We just return the root. And outside the function, we can say root.val or something.
But so another question would be, let's say if you look on the tree again.
Yep. I'm gonna erase these right here.
So to kind of understand the recursive part and kind of like a knowledge gap that I have, if
Good.
let's say the P is 3, Q is 5, right? So these two nodes.
Okay. Yeah.
These two return. These are both true. We get true.
Yeah.
No, this is not the good example. What I was gonna say is, if L and R are true, return root. Which root are we returning? Like, where are we gonna be at?
We were gonna return 4 because this check it's gonna happen. This check is gonna return is gonna be checking at 4.
Okay.
Yeah,
Yes.
it's gonna
Okay.
be checking
Because
at 4.
this call ends
Left and right. Yeah. If it's say 3, this thing is going to 3 and this thing is going to 5. And they're gonna both return back to 4. right? And in 4, we're going to be already here. So we're just going to do this check at the end.
Okay. I'm trying to think of a
Yeah, no,
counterexample.
sure. I'm not saying this works 100% because I feel like it's
Because
not complete yet.
would there be a situation where it's true, right? And but the next node that it is not the lowest descendant, but rather just another node in the way. And wouldn't that return this node, and that would be incorrect? But I'm wondering, if would
Well,
that be a situation?
it's the lowest. I don't think so because if there's both true, it's gonna return to the lowest parent or the lowest common ancestor they have, which in this case is 4. So if they have one true here, if this is true over here, right?
You're doing your thing. Sorry,
All right. All good, all good, all good. So
you're
for
doing your thing.
let's say we had 5 over here, this one over here, right? It's still gonna be 4 because 4 is the one that shares 3 and 5. And let's say
But
we had more over here, and we had 3 over here, right? Let's scratch that out. We have 3 over here. Even though 3 is further down, it's still gonna be 4.
okay, so this is where my knowledge gap is at. You know how? Okay, so this one, this one hits, and then you return true for this, correct? And it's
Yes,
always true. And then you're gonna do the right
I
side,
see, I
which
see, I
is
see.
I don't know where it's at, and we're gonna do the right side,
Yeah, and it's gonna
and then
return false.
you're gonna go all the way down here, return true. So now aren't technically both of them true right here? So then whenever you go back in the call, that's what I'm confused
Well,
about is if they're
well,
both
that's a
true and then you go
yeah.
back, they're both true. So would it be like would it mess up anywhere down here? I know I'm just scrabbling, but
Oh no,
that's kind of
I know,
the
I get you. But each call is independent to each other. Like just because there's a 3 over here and there's a 5 over here and they're both true, they don't really correlate to each other. They're like in their own different worlds. The only thing where it's gonna affect is the root 4, where they're being called, right? So 4, right? If I can I erase this little
yeah.
here? Yeah,
Erase your thing.
I. So 4 here in this case is gonna call 3, and this is gonna call 5. So whenever those 3 and 5 are equal true, the only element that's gonna be affected by those trues is 4, right? And if you have more over here, and over here, right? And let's say we have a parent down here that has a true, right? This is going to be equal false. The only parent the only node that's going to be affected by those two is the parent, because the parent is the one that's calling both, both the recursion, the left and the right.
I see.
So that parent's going to have a value, and then after that, there's a parent over here. This parent is going to have a value. This parent is going to have a value. They're going to return the value to the parent. Now this parent has a value. This parent has a value. They're going to return this parent to its parent there. Now this one has its value, it's going to return it to 4, right? So they get values and they return it to the parent. They get values, they return it to the parent. It's not like, oh, I got a value here and over there, right? They also have a value. Let's compare. No, it's a little bit of like their own little worlds.
Okay.
Yeah.
So what you're saying is if if one of them is true on this tree, let's say we
Yeah.
have a tree and there's a node all the way down here, right? If this one's true, and then this one, let's use for example, this one's true as well.
Yeah.
You won't know until they're
Ex-
both right
exactly. Until they're
here
Yeah.
until whether that affects it or not. Like
Yes,
it's not
because
gonna.
this.
This isn't gonna hold, and
Yeah.
this one isn't gonna hold at the same time.
Yeah,
They
because
both
this.
need to be right here.
Yeah, this true. What this true is gonna be sent to 3. This true is gonna be sent to 5. Right? And now 3 and 5 they got values, and now they're gonna send it those to 4, and 4 is gonna evaluate those values from 3 and 5, and it's gonna
Mhm.
make a decision based on that. But this true over here and this one over here, they don't know about each other. They only
Yeah.
know about each other when they reach the parent, and the parent has to return something, or it's gonna do a calculation on it.
Okay. See
But they're
now,
like in
I
their
think
own different no words.
I
Yes.
think that's where I had my knowledge gap at when it came to like recursive calls and stuff.
Yeah. Hey, all good,
That
brother. All
makes
good.
sense.
Hey, me too. I'm not an expert too. I'm no expert here. So I'm trying my best to like make sense of it as we go.
Okay. So let me erase. Oh, okay.
There you go.
So going back to what you're
Oh,
going back to what oh
let
to
me
what you
lock
were
it. Let me lock it.
saying. Yeah, lock that thing, man. So I
Okay,
guess
there
that
you go.
clears that. Now the other question was, since we're doing post order, you said you want to do post order. How would you know? Let me see. Post order. How would you? Hey.
No, it's over here. It's over here.
Okay. Oh, okay. Okay. Okay.
Yeah, because these ones you put it over here. No, you were good over there. Yeah.
Okay. Okay. If we're wait, you said it starts at.
The post. It's like post. Pre means before, post means after.
But where does it
So
start
like
at 0?
at 0. Yes, because you want to connect
Like
all the
what's
dots. Yeah,
over
yeah, yeah.
here? Over here?
Yeah, yeah. You
Over
want to
here? Over
connect all
here?
the
Over here?
dots? Yes, sir.
That's So I'm back. I'm back.
All good,
So
all good.
anyways, what I was gonna say was, how do you know if there's a node over here? If you're doing post order and then a node right here, how do you know it's gonna be the 6?
What do you mean?
Like
Like how?
since you're going this direction, you
Uh
hit
huh.
2, and you're
Uh
like,
huh.
oh, that's Q or whatever.
Uh
Like
huh. Yeah, yeah.
let's say it was 2, and then this was gonna be 9. You're like, oh,
Mhm.
okay, that's Q, right? And then you keep
Mhm.
going, and then you're like 9. Oh, that's P.
Mhm.
So how do you what here? Now that you got both of them, how do you know that you're gonna return 6
Well, cause
based
my
off this over here?
yeah. Well, based on that, I feel my this recursive we need to work on it because it's not entirely correct. I feel like it. I don't think this is. It's like a starting point, but it's not. It's not the correct starting point,
Okay,
right? Yeah. But my initial.
you're muted.
Hello.
You're back.
All right. Okay. Bad. Thank you. Thank you. So 2 is gonna since it's what is it? Q. It's gonna return true to 2, right? Then 9, since it's Q, it's gonna return true to 8,
Mm-hmm.
right? Then, but here 8 has to make a decision. Well, and 7 is gonna return false, right? False and true. But here doesn't my algorithm over here doesn't really um work because well, yeah, we just return whichever is true. Hmm. Okay, I think yeah. So if we have f and true, we just return 8 is true.
If
9
there's a
9
true, if there's a true,
yeah,
return true.
yeah, return true, right? Which is over here, and 2 over here, it's true, and now 6 is be like, hey, if true and true, it's it's true.
Yeah.
Boom, we know that. So if we just check as a parent if one of them is true, right?
But then if, but then if both are true and true, then that's the lowest parent. The
Yes,
lowest
that's the
node.
lowest parent. That's where we're gonna return uh the root. Yes.
Okay.
Yeah,
Yes.
yeah. And over
Perfect.
here, Oh, no, I'm not gonna unlock it. And I think over here we can add something like after if L return true, if R return true. So here's we're just gonna return else return false. Or we can combine these two and be like or R return true, else return false. Okay, yeah. I think this should work.
Okay. Now, what about the situation
Where the
when
parent,
the parent is the
Mhm.
descendant of itself?
Yeah. Okay.
I'm gonna erase this to kind of show the viewers.
Yes.
All right. So what if, like for example, two, both of the nodes
Yeah.
are.
Yeah.
So one of them will be 4. Like that.
That makes sense.
And then
Yo, we
2 could be a descendant of itself.
yeah.
So let's say it goes down, it does its thing. Oh, this ain't the right order. Does its thing. Boom, boom, boom. Change the color. So it does its thing, it goes down like this, like this, like this. It hits true right here. It hits
Yeah,
true.
4.
And then it hits true right after. Wait,
Mhm.
another question. Wait, no, never mind.
Okay, so here let's analyze this thing. So yeah, 4 is gonna return true, 0 is gonna return false.
False.
This is gonna return true, right? So here we're just gonna check if 2 is a node, right? If one of them returns true, right? We just check if the node that we're in is also equal to P or Q, and if so, return that root.
If
we have a
left
true,
if left or right is true,
it's true.
and no dot val is true,
Uh-huh.
or no dot val equals P
P
or
or
Q,
Q. Yeah.
then return the node.
True.
Return
Yeah,
true.
return
Or return
the
that
node.
node, actually.
Yeah, return root. Yeah. What do you think?
I like that.
Yeah.
What's up, Kai? How you doing?
Hey, Kyra, welcome to the stream. And that could be done right in here. Where we can say if R or R, for R or R, and oh, is this gonna be a long one?
It will be.
Right there.
Yeah. I like it.
Yep. I feel like this thing runs good. I'm not sure, but we can test run it and see.
That's funny. Just pure theory.
Pure theory,
I
we
feel
don't
like
even
it
know.
runs good.
But I don't know.
And we're gonna go test it right now, and then it's gonna say like,
No, there's not a value.
yeah, for real. Your mic unmuted again.
Hello?
There you go.
All right. Okay. There you go.
All right, you ready?
Yes, sir.
Let's
All
take
right.
it.
Do you
Let's
wanna
take it.
do a test run, or you wanna start coding it
I mean, we
from
can
the
start
go?
coding it.
Alrighty, let's do it. Yes.
Okay. So that you on your screen you have the pseudocode. So kind
Yeah.
of guide me a little bit.
All right. So first we have to do the we got to create the function.
Do we though?
Yes, because it's gonna be a recursion.
Okay.
Yeah, and then we're gonna pass in a root, right?
Yep.
And then we're gonna say if p no, okay, so we're gonna first call recurse left and recurse right. We're gonna recurse the first time to post order. Yeah, yeah, that's good. Uh-huh. Then we're gonna say if p equals root dot val, return true. And then we're gonna check another if statement, else if q
Wait.
equals root.
If
Yeah.
P equals what's P?
P is a tree node. And I think it's p dot
Yes.
value. P
Okay.
dot
Okay.
value. P dot val. Yeah, yeah, yeah.
Okay.
There we
Okay.
go.
Same thing for Q.
Yeah. So let me see. Let me think this through. We're gonna go left. Left is gonna return true. Then we're gonna go right. Then we're gonna return true. Okay. Yeah. Yes, yes, yes. So we're gonna go left. Then left. No, no, no. Okay. Okay. That makes sense. Yeah. Okay. So then we're gonna check if L and R return true. If left and R right, yeah, return true. So now we're gonna check if both left and right are true. Yes,
No,
we're
if
gonna
left and
return.
right, you return the val, the node.
Oh yes, return root. Yeah, yeah. My bad, my bad. Yeah, and then right there, and then we're gonna say if left or right, if left or right, right, and parentheses q val equals q or val equals, yeah, or return true. No, return the root. Return the root. Yes, 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 yes. Return the root. And then the next one we're gonna do if left or right, return true. And then an if statement to return false.
Okay, hold on. I have a question here. If left or right, I'm iffy about this part right here
Okay. How so?
because we're returning. This returns true, and
Mm-hmm.
does it stop? Like, okay, so for example, we do left post order.
Mm-hmm.
Oh, okay. Oh, I see. So it goes all the way down. Goes all the way down to the left side. If p dot val equals root dot val, it doesn't. Q, it doesn't. So then, if left and right, nope. If left or right, nope. If left or right, nope. Return false. So this is false. Then it goes to the right, all the way to the left. Wait, no, no. It returns false. It's right here. Goes to the right, all the way to the left. 3. Yep, that's not it. It goes right all the way to the left, but there's nothing, so it goes to the right. It's gonna return false again, right? And
Mm-hmm.
then you return false. So now this one has false and false, correct?
Mm-hmm.
And then you return false again. So these two are false and false. This one has false and false too. If p dot val equals root dot val, p is 2 and equals root dot val, return true. Okay. So now this one is true. It goes back to here. It goes right, all the way left. False. False. True. Okay.
Yay.
So when will this hit?
That would hit. Let me see. Oh, what are we trying to say there? When there's one left. Okay, this will hit when there's like, for example, it's taken 3, right? Let's say p was 3, right? So we go to all the way to the left. 0 equals false. 4, right? 0 equals false. We go to 3. Yeah, we go to 3, which is true, right? Returns 4. We go 3 returns true. 5 returns false, right? So we now got 3 and false. 4 is not equal to p. 4 is not equal to p nor q. Left and right, since it's right and left, it's not gonna return the root. Then the if left or right, we got a true, but 4 is not equal to the p or to the q, right? Therefore, we're gonna go to left or right. So now left, for sure, 3 is true, right is false, so we're gonna turn true, right? Because 3 in this subtree, we got 3. So now we got 2 is gonna have left on the right, no, false on the left and true on the right. So now we have left and true, and now true 2 is gonna hit the last if statement and it's gonna say, all right, left false or right true will return true.
I see.
Now true is gonna return 6.
I see.
And then we need a base case in the top. If we reach the end of the list, we're gonna say if root equals none, we're gonna return false. Yeah, like that.
All right. What about this one right here?
That too. So we're gonna go 2 left is gonna hit on the root, right? On the first if statement, is gonna be false on the left, and then we're gonna go to right. P is gonna return true because it's Q or something. So we have left and true, right? And then wait a minute. Oh, Vas, that's a good one.
So you go left. Q equals 1. Yep, returns true.
We go right. That's false.
Then that's when this one's.
Yeah, but it's gonna hit the first if statement.
Then should this be put at the top? I think so. This one should be at the bottom. I think there's.
Yeah, that's like the last.
Yeah.
I mean, yeah, because we're checking the children. Maybe.
Huh. The problem here is what again? I think it's just this right here. This is a check.
Yeah.
But like you said, it's gonna return. Wait.
True.
Yeah, it's gonna return true, which we need to return the root.
Yeah, I think that if statement goes on the top. You want to run it and see what happens?
Yeah.
Okay.
That's what we're talking about.
That's the start. We didn't get no errors though.
Yeah. Well, it's because we didn't return the
we didn't even call it. We didn't even call it.
All right. Lock in.
Bro, I thought
Lock
it was.
in.
I
Lock
was like,
in.
damn, bro, that was fast. But then I'm like, wait, we didn't even. We
Lock
did.
in.
We
Lock
did.
in.
That was. It was fast, and we had no errors. Oh man.
Node equals like that.
Yeah,
All right.
there it is. Had those errors. Mm.
Is it saying that you're returning something that might not have a value or?
Don't think so. All right, go for it. Let's see.
Bruh. Woohoo! I don't know if that space meant anything, but I'm just gonna check it. All right, you're done.
Return node. We just return node.
Okay, that's all I needed to do. Turn node.
Oh, we have to return the node.
Yeah, I guess so.
Okay.
So number
Okay.
2. We got 2.
2 4.
Oh, we outputted 6. There should be
Mm.
2. Okay, okay. Hmm.
Okay.
So that means this one isn't hitting.
Yeah, it's not. Uh, let's think about it. Let's think about it. So we got 0 false, 4 true. Now we go 0 false, right is true, and I don't like it.
False, false. If left or right equals true, return true. False, true. If left or right
Which is true.
return root, which should be this. But it's returning this. If left or right.
I think I know what's happening. I think we're just returning because since we're returning true and false, when we return a root, right? It's not automatically returning it
Ending.
outside.
It's not
It's just
ending it,
return.
right? It's returning it to
Yeah,
the
it's just
outside.
returning it to left or right. So in
Uh-huh.
this case, 2 instead of like exiting, it's returning root to 6.
Yep.
Right. So now we got uh
Mateo, what's up?
uh
What's up? What's up? Yo,
yo
yo,
yo yo
yo.
yo yo, welcome to the stream, brother.
Yeah, I think
Yeah, because if you do a print statement, instead of a return, you print the root that val, we're gonna get 2.
we're gonna get multiple. Yeah. And it's gonna print 6 as well. Or
Well, no, if you do a print here of the root that val, you're gonna get 2. I think.
yeah, because like you said, root's held right here, and then this last condition checks, and then it's gonna run it again.
Mm-hmm.
So this needs to be a boolean, or how should I say, like we should check if it's a boolean, because if it's not a boolean, that means it's a node, and if it's a node, we don't want it. We want to. Does that make sense? Something along the lines of that.
Yeah. Yeah. Yeah.
Somewhere to say like if it's if left or right is true, like if it's a boolean, not if it's a node, because it still counts. If left is a node, that's still true because left is not none or false.
Mm-hmm.
That's one way. One way I'm thinking.
What if you maybe it might not work, but what if you put the left or right in parentheses? Just throwing things out there.
Okay.
Let's see. Oh,
Did I miss something?
okay. I see. I see. Yeah, because um now root, since we're gonna returning root, right? Root is being passed as the left for root dot left for 6, right? And since and then now left is root. Let me see.
Yes. So this is a node, and then this is a boolean, and you can't compare either or.
Oh, it's in the Boolean object has no attribute val.
Right? Because like you said, wait, no, yeah, like you said, we're comparing. Oh, now left is a node. This is a node and not a boolean.
Mm-hmm.
So then when it compares left or right, like you're comparing with the parentheses, now you're comparing the, aren't you comparing like the values of it, or I don't know, something like that. But I see where our problem is that we're returning two different types of things that
Yeah,
will go
yeah.
in the same variable,
Mm-hmm.
and that will run into problems like that, and that's
Yeah.
the problem we're having.
Mm-hmm. Yeah, yeah. Oh.
And this one, we just need to check to see if left um
Hmm.
hold up, I had it. We need to check if the left or right is a node, and if p dot val and the rest of it. If it's a
Yeah.
node, if left or right are nodes, then you want to return the left or the right. Wait.
Or
Yes.
what if we just do an if statement and say if left is a node and if right is a node, just return the
Return
node.
the node, yeah.
But how do we check if
But
it's
you
a
gotta
node?
say if this as well. Because I don't think this condition, I don't think we care if it's true or false, or we don't need a boolean. We just need to check if it's a node. Yay or nay? I gotta think it through. Yay or nay though. Let me think. 0, 3, 5. This is gonna turn into, this is false, but p dot val q.val is going to return it to true. This is false. So if true, right's going to be true. And
What if we just
p.val.
create a variable outside to store the node? And we just have true and false inside.
Okay, so we're always going to return, let's just say, for example, it's called, I guess, node. Wait. Because, like, if let's say we do have a, or is this what you're talking about? Like a node like this?
No,
Equals
like
none?
outside the definition, the function.
And how do you want to access it?
Well, it's a global variable, so the function is gonna be able to access it.
You lie.
Uh huh.
It's July. You being serious?
Yeah.
So, okay, hold on. No, you will need this. So you don't need to initialize the variable for that?
I think so, but I think since I'm not sure how variables work in Python because I was reading a little bit that you cannot change variables in a function, but you can change the list. So we have to do node when we declare it. We can do node brackets 0 will equal none. That way we have like a list of just one element, and we just switch the content of that element. So it's node bracket 0 then equal to none. Uh-huh. Yeah.
So this right here initializes an array for none
Of
node?
one element. And now we just switch the element in there. Yeah, just like that.
Really?
Yeah. But now we have to return. Now in those if statements we have to return something though. Because now we're gonna go all the way down. For example, if that statement we're gonna return true there, because that means that there is yeah. Yeah, we have to return true because that means I'm the node and there's a node in my descendancy. And return true, yeah.
Like this, but we don't care about this though, right?
Yeah, we don't yeah, because the node we already have the node saved in the variable, so on the return statement at the end, we're just gonna do return node at position 0.
But they're still gonna give us our error right here. Do we take out the parentheses?
I mean, I don't think so, because now we're just getting left and right. But if you want to, I'm down.
Oh, I
Yeah,
see what
let's
you're
see.
saying. Let's see.
And then we're gonna get. Oh, you put mode, mode. Huh. Maybe because it's a keyword.
I don't like that. The syntax is kind of confusing me right there. That's why I was
Well,
asking you.
we're just creating a.
Could it be like this?
All right, yeah, I think so. And then just at position 0, we're just gonna equal it root. Yeah, yeah, I think that works. Okay, at the end, here's at the end right there. You're gonna return position 0. Maybe fingers crossed. Hmm. Hmm.
We were so
What?
close, man.
We're so
I don't like
close.
this. I don't like this idea.
Okay, so we can scratch it out. We can scratch
No,
it
I'm
out.
not saying
No
it's not gonna
problem.
work. It's just I don't like it.
Yeah.
Only because then it limit. I only don't like it because like it gives us this weird thing right here where like we're returning something but we don't need it technically, and like it just feels
Yeah, I
like
get you. I
dirty.
get you. I mean, you don't have to
But
store it in a variable. You don't have to do the blah.
I don't.
No.
So then, what's the problem here? It says it can access it, or is it? Should I do this outside of the definition?
No, I don't think so. I remember doing something similar to this. Let me check. Let me check. Never mind. Hmm. Cause I don't know. I think the code is a little bit messy now.
I do. I agree. I agree.
I think we should I don't know, refactor it. Oh, bro, this chair one thing is gonna break it. I'm a fall. We have to think it through. Return true or false.
I say you check if left or right is not a boolean. Like there's a function where it says like is bool.
Uh huh.
If it's not a boolean, and the other side is true, return the one that's not a boolean.
Okay, go for it. Yeah, let's see. I'm down for anything right now. My stomach is growling. Bro.
Okay, so can you get the function? Do you know what it is?
Is
Uh,
Boolean?
is bool something like that?
Give a sec, give a sec. Um, you can use type.
Okay, okay. So if
Type value equal bool.
like this,
Yeah, equal bool. Yeah.
I wonder if I could.
Hmm. But when a variable is it's not a boolean, what does it mean? Does it mean like because I feel like if the type is there, yeah, if it's not a boolean, that means that there's a node
Yeah,
in there. Yeah.
yeah.
And, are we gonna return true or the root itself?
Turn the root. Because remember, this is like if you're at 6.
Okay, I see, I see, I
If
see, I see,
if the left is not a boolean,
I see.
and wait a minute. Nah, I don't know about this.
Oh, I think we have to return true. No, never mind. No, we're not returning.
Because the
We
issue
return the
is
root. It's because the issue is that 4, right? We get
it's true.
false. We get a
False and
false
true.
and a root. We get a false and a root, right? And then we say, all right, right is not a bool, right? 2 is a what's it called,
Roots.
a root, right? It's equal to root. It's equal to the P or Q, right? So we had to return 2. So we had to
Yes.
return the root,
Which is
not
left.
no, because if you return left, you're returning 0. If you return right, you're returning 4. We had to return 2.
No, but the problem is wasn't that we weren't returning true. It's just that whenever we hit 6, and it was checking, this is a node and this is false. It's gonna it was gonna return 6 again because technically
Yeah.
left or right, and this one equals P or Q or whatever. Then it returns this. But
Okay, I
we
see. I
need
see.
2
I see.
to stay in the
Uh,
call, and then like always return true whenever you're done.
I see. Okay, I see. I see that. I see that now. I see that now. Yep, yep. Yeah, I like it. I like it then.
But what I'm questioning now is that 0 is false. This is true. Q dot val equals root dot val return true. False and true. 2. If that function that we had was to combat that. So
Mhm.
that's why this is not really combating it anymore because or do we need because remember, okay, look, if left or right and that was the code, correct?
Mhm.
Now what minusing, like ignoring this right here, ignoring this, what's what code is gonna say return 2 as the lowest descendant?
When it's 3 and 5, 3 and 0.
No, like what code in here is gonna say return 2?
What do you mean? What code?
Like which code acts is combating that issue that if 4 is true and the parent of 4 is also P,
Mhm.
that we also want that's a descendant of itself, so we want to
Mhm.
return 2.
Mhm.
What I'm saying is that this code right here directly combated that issue.
Mhm.
But if we change it to this, I'm wondering, does that still combat this issue?
I think so, because you're checking if left is a bool, right? And then you check if 2 is part of it, and if so, return left. You get me? Because
Okay, so
that if statement, you're checking 2 as well.
but if we're on 2 right here, right,
Mhm.
and left, that's a bool. Right is a
Mhm.
bool.
Mhm.
So these are never gonna hit.
Now you go to the other statements. Now
Okay.
you go if 2 is pure Q, we're gonna return true, right?
Okay.
Yeah, and then
Now
we
this is
gotta
true,
check what that's true. True is gonna go to 6.
and then that's fault. Like that's gonna return 6 is what I'm saying. Or it's not. It's gonna get an error or whatever because this is true. This
Mhm.
is true now,
Mhm.
but it should be the root.
Are we assuming that 4 is Q?
Yeah, we're assuming 4 is Q. We're like this example right here.
Well, in that case, since 0 it's not 0 is not a bool, is a bool, we're not gonna do the first if statement. But
No.
4, since it's right, it is not a bool, right? It's a no. Now we're gonna hit that second if statement. We're gonna check. Now we're checking if 2 is Q or P, and if so, we're gonna return right.
But 4 isn't a. But 4 is a boolean because of this right here.
Oh, I see. I see. Hmm. Well, you can switch it then into a bool. You can check if this, like you had originally had it, if it's a bool.
Say that again.
Like you can check if it's a bool if instead of not being a bool, a boolean.
And then what?
Well, now you don't have that problem with you. Now you just check it if it's true or false. I feel like we went wrong with returning the root. I think we should just stick with like true and false and have like a counter or something, a parameter, like keeps track of that of that number.
We were so close, man.
Mm-hmm.
We were so close. What? Where did we go wrong? I feel like we're so close right here.
It's because there must be a simpler way that.
If 4. What if. What if we keep it to return root or return none?
Where?
Like instead of true or false, let's do return root or return none.
Oh, I think that would work. Yeah.
Feast fest or feast or fest. Um, yo, just coded that one up. Hey, if you
Oh,
wanna
welcome to the
if you wanna
stream,
give
brother.
us some hints or tips and tricks, feel free to tell us right now because we've been working on
Yeah,
this for an
we're
hour.
stuck.
We've been working
We
on this
are
for an
stuck.
hour. But that's
Oh
awesome.
man.
That's awesome to hear. Is this problem 235? That is correct.
Yep. Yep. Yep.
But that see, I think we recognize where, like you said, where we went wrong,
Mm-hmm.
and that was when in a recursive function, returning different types can be problematic.
Yeah.
Could be for beginners. Um,
Mm, I don't know. Let me see. Let me go back to schedule. Let me think this through. Let me think this through. Hmm. So if this one is true. Can I use Google for this time?
if you want to,
Yeah.
if you want to, man. see, is there any tips and tricks on this? Okay. Chiefs Fest said, think about the fact that it's a binary search tree. If P and Q are on opposite sides of the current node, what are what are on oh okay of the current node you are on, what does that mean? Like you are on the root and P is on the left and Q is on the right. I see. Oh, I see. Okay. So Cheese Fest is kind of looking at it as like it's a use your knowledge of binary tree, search tree, right? If the current node is 2 and P is 1 and then Q is 5, you know that those are going to be on opposite sides. So return that current node that you're on.
Oh, so you just check if they're left and right. If they're
Yeah.
your okay, I see. That makes a lot of sense. Huh.
Oh my god, dude.
Man, oh
Who
man.
said post order, bro?
Bro, what do you mean, bro? I was ready to go with post order,
Who
bro.
said post order, man?
Hey, bro, chill with. Hey,
You,
you said yes to the post
that's
order.
on me. You know, that's on me.
Hey.
Dude, there's no way. Okay, so if it's on the same, you just keep going
Yeah, just
until.
get each node and say if first you check if you're one of those, and you check if it's on the left or on the right. Yeah, that makes sense. So you keep going, you traverse the binary tree, and in each node you say if P is less than Q, no, if Q is less than node, and if node is bigger than P, that is your node, right? So you have to be less than, greater than, or equal, and that's your node.
Okay, also, my bad. She said they used post order as well. So, hey, that's on me.
Oh
That's on
my
me.
god, bro! Oh
That's on me.
my,
I
damn!
I admit to my mistakes. I
Mm.
admit.
Bro. Bro, that hurts. That hurts.
Cheese also said, also, you should keep in mind if, for example, P is the root and Q is a child, that's also optimal. Okay.
Yeah.
Okay.
Oh, I was on the right path. You know, you know.
Yeah. You're
People be
never
hating,
mind.
bro.
Never
No,
mind.
I'm
I'm not gonna
kidding.
say
I'm kidding.
anything.
I'm kidding, brother.
I'm gonna keep it quiet from now on. I'm gonna be
All
hush.
right. So we just have to traverse again.
If not, what do we return if it's
Um.
we'll skip that for now.
Yeah. You can just put return. You can do. We're gonna traverse left
Yep.
first.
If so now we're checking if left.val. No,
Mm-hmm.
but this is post order, correct? So we're over here
Yeah.
at 0.
We have to check. So return. We're gonna return nothing and nothing, right? So you're just gonna check.
If
Bro, you see, that's what I hate. Cause what do you return?
Cheese Fest, what do we return?
That's that's our only dilemma. We no, but we don't know how well me personally. I don't really know how the returns how they work.
Um,
Oh, return the nodes. So let's say if root dot val is greater, do we know if for a fact that p is always going to be less than?
no. But you could say like, well, the way I was seeing it is, I was thinking that. Oh, that hurts. I was thinking that if the node is P or Q, right? So let's say a node is P, and the parent node of it is greater than P. And let's see, I was looking at it from the top down, so I'm a little bit confused how it's gonna work in post order. That's where I'm kind of getting confused at, because I was looking at it like, okay, you're at 6. Okay, where's P? Where's Q? And then, oh, if P. Wait a minute. Yeah. If P is less than this current node, that means it's on the left hand side. If Q is greater than the current node, that means it's on the right hand side. I was thinking of it like that, but when it's post order, now I'm confused. Like how would you?
Well, we should just check the nodes the same way, but just in reverse. You check 0, 3, 5, 4, 2, 6, 7, 9, 8.
Say that one more time.
Like you check like from down up, or like you check 0. Whoa. Cheese Fest said he did pre-order, so you might be right. You know, he took it back. Damn. So he did pre-order where
So
he went
so when the rabbit
620.
got the gun.
Damn, bro.
No,
Oh
man,
my
my bad,
god.
my bad, my bad, my bad.
Damn. I'm kidding.
That's
I'm
on me.
good. I'm
That's on
good.
me. Well, see,
Okay.
well, that's the only confusion I have. And if we can figure it out, I'm down for post order. It doesn't matter. But like I said, I
No,
was
listen.
thinking of it from a
Yeah,
top
me too.
view
I was
to
thinking it the same
compare.
way. Yeah, I was thinking the same way because Cheese Fest said post order. I was like, all right, we just go down. But in the beginning, before he said post order, I was thinking the same, like start from the top. That way, as soon as we hit, like, oh, both values are on my right, good, right? But the thing is, no, yeah, we should be good. Yes, this is a pre order. Let's check if each value, if it's left or right. If so, return that value. Time to move. Let's
Okay.
go. Let's go. One,
If
two, 1, 2, 1, 2.
P less than val and Q yeah or nay.
Yes, but we don't know if P is always going to be less than root out.
Oh, that's brilliant. That's brilliant.
So check the constraints. Okay, we don't know then.
Yeah.
So we go
You're
back
right. You're right.
and we just we also have to do the greater than or equals. Because what if they're equal? In this
It can't be
case.
equal.
No, but equal to the node. To the root.
Oh yes.
Like
Yes.
yeah.
Yes. Yes.
So
Yes.
control C, we can do the same thing. Control
Control C.
C like
Z.
zebra. Yeah, and then we just copy and paste that, or another one, but we just flipped. Like the if statement, like the actual if statement, put that in parentheses, the first, like a greater than, less than, then put another one on next to it with just an or in the middle. Just flip the signs. Don't forget the equals. There you go. Equal. There we go. Now go to the other one. Return that. So
And then if it's not that, then that means they um. But also,
no,
what if,
I
like you said, no, okay, hold up, wait a minute.
I think that works.
You lie. It's July.
Not sure. And I don't think we need left and right, because left and right, we just return root. No, we had to call it first.
Oh man.
Oh, P dot val. All right, so CheeseFed says because it's a binary search tree, only go to the left if both are on the left, or right if both are on right. Smart thing. Put it no.
Okay.
I see. I think I know why. Because we're
I
not
have no
saving
idea.
the value.
Yeah.
Bro, why can't it just like be printing, bro? Why do we have to return something? Like print, return root, print on that if statement, print it. What do you get? 2. All right. Now online post order, we're gonna hold the value there. We're gonna say left, right, and we're gonna return whichever one is not none. Return if left equals none. There we go. Left, else. Uh-huh. Uh-huh. Uh. Let's go. Let's go. Let's go. Let's go. Okay. Okay. Okay.
Now let's check some test cases. What was it? 5 and 6?
It's 5 and 6.
Is there another one?
Ooh, right there.
Oh my gosh. There's 2 and 3.
Uh-huh.
One more. 1 and 4. Right. Fingers crossed, everyone. Oh, perfect.
Oh, which one? I think it's 4. I think it's 4.
He,
Go to 4. Go down to the values. No, that's.
he said, "Can I not post links?" I guess not.
Oh,
Can you
you can
try?
go. I don't think so, but you can post it on the Discord. Discord link. I'm gonna send you. I don't know. Here you
Who's
go.
gonna
This is a
send?
Discord link. If you want to
Who's sending
join.
Discord?
I don't. I think case is number 4 because it's not a binary tree.
Okay. Where did we get that from? From this over here?
Yeah.
All right. All right. Submit it.
Give me a sec. Give me a second.
Okay.
LeetCode test cases.
Did you send them the link or no?
Yes, I sent him through the chat. Cheesefest, confirm if you can access the link and join the Discord. That'd be pretty cool.
I don't see it in the chat.
Really?
Yeah.
It's under my name. Second to last.
Yeah, I still don't see it.
Really?
Yeah.
Huh.
Maybe that's just
Send it
me.
in. Oh, he can't see links. Okay.
I can't see the link either.
All right. If you go on the disc on the what's it called, on the description, I think as admin Carlos, you can post them. I'm not in on the account right now,
Oh,
but I
okay.
think you can pin it. Not sure.
I got you then. Give me one moment. That should be it. I'll pin it.
Yes,
There you
yes,
go.
yes.
Okay, anyways. You want to submit, man? Come on.
Yeah, I submitted. Let's see.
All
Let's
right.
see.
Maybe there's a edge case. All right, come on.
Let's go, baby. Let's go, baby.
What are we talking about, man?
Let's go,
Good
baby.
stuff, man.
Let's go, baby. Let's go.
What we're talking
Let's
about.
go. Damn, bro. Hey, Cheese Fest. That's how you,
Cheese
buddy.
Fest.
That's how you. That's how
That
you.
was you.
That's
You
how
know
you.
that was you, right?
That's you, Cheese Fest. That's you, Cheese Fest. You know.
You know that was you.
That's you. That's you, buddy. That's you.
All right, I put it right here. I don't know if you can see it. Yeah, you can't. Right there. Thank
That's
you,
you,
Cheese
Cheese
Fest.
Fest.
Boom. Put you on a note. Wow.
Oh, damn, brother.
What happened?
No, that's. Oh.
You could optimize it a little by only going to the left bolt
Yeah.
on the left. I see what you're saying. So would that be
I'm not sure how though. Like I know it's possible, but not how.
I don't know either. Anyways, we got it done though. That's all that matters. All right.
Nah,
Jose,
brother.
where you at, man?
Yeah.
Where you at?
Do you mind if we call it here, brother?
You want to call it here?
I'm starving, dude.
All right, that's no problem.
Are you sure?
Yeah,
100%?
that no, dude.
Yeah.
Does it look like I'm upset?
I don't know. I'm just asking. Just making sure. Just making sure, buddy.
But we gotta be transparent, man. We gotta let them know where we're at mentally. You know.
Oh, that's true. Right now, I'm like at 7. Honestly, I
7?
thought this. Yeah, I thought this was gonna be an easy problem, but the fact that with the return statements and stuff like that, didn't really sit well. I don't know. Today was more like I don't know. And then I think it was the fact that I was doing a little bit of homework before the live stream,
Okay.
and I had that stress already piled up. Now with the fact that I thought it was gonna be easy, which it wasn't, I was like, ooh, fuzz. You know.
Yeah.
But
I mean,
I'll take 7.
okay. I mean, I think the problem was really good for me.
Yeah.
It helped me understand recursion a little bit better.
Yeah.
And so I actually really like this problem, to be honest with you.
Yeah. I liked it too. I liked it too.
I like how we went from like 50 lines of code to like
To
20.
a simple thing.
So that was right in front of us this whole time.
Yeah, and we didn't even see
and
it. We didn't even like
and Cheese was the one that to show us. So
Cheese
appreciate
Fest.
that, Cheese.
Cheese Fest. Hey, Cheese Fest, thank you, buddy. I hope you stay here. We do live streams every Wednesday at
Every
10.
Wednesday. Yep.
Today was a little bit of later stream and a shorter stream, but usually every Wednesday we're here at 10 a.m. If you're up and early, we're here grinding the LeetCode and stuff, and hopefully you stay here, buddy. And thank you so much for this help.
But
Yeah.
yeah, that's about it for me, man. If you want to call it.
I think so, buddy. I think so. But hey, next week we're gonna stay here a little bit longer.
Next week.
I'm
Next week we
gonna try my
got
best to make it longer.
we got these mediums coming up, so
Mm-hmm.
next week might be a little tough, man.
Yeah, but hey, I'm here, buddy. I'm here.
All
I
right.
am here.
Do the final
Alrighty.
words, man.
Alrighty, all right. Thank you guys for coming in. Thank you, Kyra. Thank you, Cheese Fest, for coming in, tuning in. Make sure to subscribe, leave
Don't
a
forget
like,
about
share.
Mateo.
Oh, Mateo too. Mateo, I think Mateo was here. Yes, sir. Thank you for tuning in, Mateo. It's a shorter stream. I think we did an hour and 30 or so. But hey, we're still here. We're still grinding. We're still on the move, right? And thank you guys for coming in. Hope you guys enjoyed it. Hope you guys have a great, wonderful day, night, evening, morning, whatever it is. You just have a great day. So, see you guys. See you guys next time. Bye bye.
All right.
Alrighty, buddy.